I am with you. Thank you. And thank you for the invitation. I assume that you will be able to see my presentation.
Yes,
No? Yeah, no?
please. We are
Excellent.
able to.
Excellent. Um, and first of all, I of course would like to thank you and I just need to hang on, hang on a bit because I can see that my presentation is not moving forward. So if I may, I will just drop out once and re-enter the presentation again. It's always a struggle when you try to test this, you do it, and then all in a sudden, then you don't have the connection to the presentation.
It is back again, Jeppe. So.
Yeah, but I can't move my slides. I can move my slides. Oh, there it is. Okay, excellent. Sorry for the interruption. First of all, thank you for inviting me to speak on this pertinent subject because it's very important. Indeed, my name is Jeppe Skovbakke Juhl. I'm educated as naval architect and has been working with the Maritime Safety and Security at BIMCO for almost 9 years, I think. With the 15 minutes available, I want to keep the presentation of my organization, BIMCO, to the shortest possible by saying that BIMCO is one of the largest direct membership organizations for ship owners and charters and brokers and agents. And we are covering in total 65% of the world fleet. I have added some slides at the end of the presentation, which you can look into directly if you want to know more about BIMCO. I think it's fair to say that the COVID-19 pandemic have had a widespread and probably long-lasting implication also to shipping. But we also have to admit that there has been some positive side effects associated with the pandemic, as we have re-examined our routines in the maritime business by taking let's be honest, a gigantic step forward with regard to digitalisation. And that is actually a very positive move, which we will benefit of in the future. Just 2 presentations ago, Michael showed this slide, and I actually took a dump from his presentation and put into my presentation because I think it's a good start of my slides. Michael was highlighting some very important subjects. It was about connecting. It's about predicting, which is a kind of exchange of information. It was information transparency. It was integration, and the last box in the bottom of his slide. I will not touch upon the scholars and so on. But Michael's slideshow show a very important, how important maritime informatics actually is to shipping. And I can only recommend that these 2 books he was explaining about, they are very relevant. So I can only recommend them. But we have to admit that shipping is a global industry, and therefore the solutions on digitalization and information exchange will also have to be global. So in that regard, my presentation will be very practical, and it will be about implementation. Maybe not as much related to these kind of technical information which Sverre talked about in his presentation, but more on the administrative and operational kind of information between ship and shore. But to start with, I want to bring your attention to IMO regulation, which came through in 2016, I think it was, saying that public authorities need to establish systems, electronic systems, to assist ships' clearance processes. And that is actually quite important, because with this new regulation, we actually kickstart the maritime digitalization with regard to information exchange between ship and shore. Because now it was a kind of mandatory thing that you need to have an electronic system in place, both on board the ships and ashore, whereby you can exchange information. The regulation is actually, in one way, very positive, because it's pushing for digitalization in the maritime industry. But it's also, in a way, quite alarming, because at the same time we are opening for loads of different solutions. Flag states may have solutions, port authorities may have solutions, all sorts of vendors and software or maritime services provider may open for their individual developed solutions. Not to mention the maritime single window, which is individual in many countries. So at the same time as embracing the good regulation, we are seeing a tsunami of solutions which actually the ship will have to interface with. So we may have loads and loads of solutions, and the ships may not interact with these good solutions. So collaboration is key to the solution. Otherwise, we will end up in a disaster. This slide shows that standards and harmonization is crucial, and in particular international robust standards, in order for us to do these interactions and interoperability between solutions. So the most beneficial solution would be if we could develop a robust data model map across the main solutions already established by involving those parent bodies who have developed these data models already. So we should not develop something new, but capture and put forward a common solution comprising what is already at the table. It should be, of course, technology neutral, so we don't have to put new equipment and additional equipment on board. The best way to illustrate this is that we have a number of different information domains. We have the trade data domain, we have the customs data domain, and we also have a maritime domain whereby we exchange important information between ship and shore and vice versa. I've showed this with the three bubbles at the screen right now. The issue is that when we have the data sets, the different data models and data set, we will also have an interaction between them. And where they overlap each other, these information elements or data elements, what we call them, should be harmonized. That is the key to a proper solution. And this is what we have done under the IMO umbrella. We call it the IMO reference data model. And I want to go through this data model. One side, I don't know, to me it's this side, probably this side, the blue box. It will show all the various data standards we are using today in the maritime domain. There may be more, but it's only examples. And these data sets, the data elements, we want to put into the maritime services. It could be put forward to the immigration, to the customs, to the police. We have pre-arrival information and terrorism and so on and so forth. So how to do this? It could be beneficial if we could have one kind of center of doing this. And this is where we have developed the IMO reference data model. Continuing on the left side, we have the standards that can be broken down to data elements, and combined it will be data sets. It could be data set on stowaways, it could be port logistic, it could be certificates, for instance. The other side, we would have to push the data model, the IMO reference data model, to the various nationalities. It could be Singapore, Korea, Norway, as mentioned, and that could also go into API solutions, maritime single window, port information, port providers, and so on. And this is why we call it a kind of bow tie solution. That is, of course, a illustration. It's an idea, and this is the idea, the concept we have used to establish a precise and concise solution at IMO level. I've simplified this illustration that we have the ships. If they have all the information on board already, we can put that into the maritime single window, the authorities, the service providers, whoever needs to have this information, and it will go through a number of different APIs. But if the APIs speak the same language, then we can communicate. I mentioned the tsunami of different solutions. Just imagine that we have, I'm just mentioning 2,000 different solutions. We have 70,000 ships, and then you can combine and see how difficult it will be with one only solution. But if we have one language, so to speak, one data model, which everybody could implement in their various software solutions, then we could actually have a global standard for communication and exchange information. Today, this is how the IMO reference data model looks like. It's only a very small part of it, but you can see to the left that it's quite extended. The data model is quite extended. I have zoomed in a bit more to the right, and everything is related to the voyage, to the persons on board, to the ships, and so on and so forth. So every single little data information block is associated with a ID, so you can exchange like having a small Lego brick. You will send the Lego brick from the ship to the shore, and the shore will do whatever it would like with it, as long as you only send it once. It will reduce the burden both for the ship and to the receiver. We have simplified this in a kind of machine-to-machine global solution where we call it 1 + 1 is more than 2 is 3. Because we have the flexible solution in the middle, and then we will have the IMO reference data model, which gives the data element, and that will be in the center of this flexible solution. So the solution will not change. It will only be expanded by the number of data elements in the data reference model. Now I want to give you a small case on a very pertinent issue. Sverre talked about it. It's just in time. And I will give you the example because the pressure is right now with the greenhouse gas strategy and focus on the port efficiency, that we need to focus on the efficiency we are having, reducing the emissions to sea, and also increasing the efficiency at port so we can use less power and do everything more efficient. This is put forward in the just-in-time arrival concept. There are loads of good information about the just-in-time concept, so I don't want to go through that, but it's in general that it refers to any action that reduces the idle time of the ship in port by minimizing the delays. And to do that, you need to have early and good communication between ship and shore already, way before the ship enters into to the national waters. I will put you a picture of port congestion. It's in port of Fujairah, and the other one is in port in Singapore, and I think the third one is port of Ningbo in China. And you can see all the ships is waiting. And the previously at least, the normal has been that you will go full speed ahead due to your contract, and then drop your anchor and send the notice of readiness that you are now available for discharging your cargo. But sometimes you will have to wait outside the port, simply just waiting, either because the port is not ready or for various other reasons. But if you actually could have slowed down your ship because you was made aware that the port was not ready, then you could actually slow down your ship, and by that reduce the CO2 emission and save your fuel cost. So instead of having port congestion, you would simply just strengthen or lengthening your voyage to arrive to the port in the right time and avoid the idle time just waiting. The UN body Trade and Development, the UNCTAD, has done a small example saying that the normal waiting time in port is 7.3 days for a bulk carrier. The average waiting time is 3.5 days, and with about 140,000 port calls for bulk carriers a year, that actually represent a cost of almost $5 billion a year. That you cannot just use or say that is savings, but it's potential saving. You may save a bit of it, and that is actually to the benefit of the total industry. So what we did, with this in mind, we implemented the just arrival concept into the IMO reference data model. We had some data sets related to the position. It could be available at anchorage, at the terminal, at the pilot boarding place, at the berth, and the berth position, and so on. And at the same time, we developed some timestamps to submit from ship to shore. And some of it is well known. We have the ETA, the estimated time of arrival, but we also introduced some shipping segments fairly new, the requested time of arrival and the planned time of arrival. And these new elements are simply to notify the port that we are on our way, and the port says, okay, we know you're on your way, please be at port at this point in time. And then you confirm that, and you will update continuously throughout the voyage between ship and shore in such a way that when you arrive to the port, or the terminal, you will more or less, ideally, you will go straight into berth and or discharge your cargo. This has been implemented into the data IMO reference data model in order for ships to use this data model in the systems and communicate seamlessly and easy with port, very much along the same line as Michael told in his presentation. There's of course some contractual issues, and it's quite complex. But BIMCO, who are normally doing clauses and charter parties, standard charter parties, we have also developed a just-in-time clause, which is available first quarter this 2021. And I don't want to go into details into this contractual considerations, but I'm just saying that now we have a contract in place in order for those companies who want to make use of this just in time, they can use that. So how is this IMO data set developing? right now, next week we are having an IMO meeting where we will discuss this matter. And right now we are awaiting maritime services, a data set related to maritime services according to the IMO e-navigation. We have some acknowledgement recipients which needs to be implemented. We have some safety information. We have ship certificates, which is almost ready to be implemented. But in the future, and data sets are submitted, it's just not discussed and included in the data model at this point in time. We are also information about environment information, ballast information, ballast water information, and so on and so forth. So it is incrementing, or it's increasing. But at this point in time, we have about 350 standardized data elements included in the model, and it's growing. So within a year or maybe two, we have more than maybe 750. So to my conclusion, you can see the slide from Michael. We can check that connecting what happened at sea is what happening at shore. We know about that. Enhancing the predictability and movement of operation, that's just in time, that is included in the model. Increased information transparency, that is included as well. Seamless integration with multimodal transport chain, that can be done by use of the standardized and robust data model as delivered by IMO. So close collaboration is the key. The admin burden is reduced a lot by introducing this data model. We have calculated in one EU project some years ago, we calculated that we will have a reduction of about 80% of the admin burden on the ship to avoid the interaction between ship and shore. The just-in-time case is illustrating a low-hanging fruit. It's fairly simple to implement, although you need to have the contract in place, of course. So the final word, global standards and collaboration for easier digitalization and integration is the key. And for some part of it, although not the hardcore information with technical and engine control information, that is not part of the model, but admin burden, the operational burden, and the navigational, the administrative data, the operational data, and the navigational data is at this point in time included in the data in the model. And finally, a very important thing is that the ISO standard, the 28005, is actually adopting the IMO reference model on a short updating frequency. So everybody can look into the ISO standard and use that in the specification in case they want to specify something in their contracts. I think that was more or less my words